Morning, everyone, and welcome to our exclusive webinar on Tech Talk HVAC. I'm Nisha George, the Assistant VP of Smarter Spider. Before going to the presentation, I would like to give a brief about Smarter Spider. Smarter Spider is part of Blue and Gray innovation. At Smarter Spider, we focus on making existing buildings smart through our wireless and IoT solutions. We offer smart building monitoring system solutions for fire, energy, HVAC, and water management. So talking about our system, we control and monitor everything on a single platform. Our systems are affordable. We have modular systems. The decisions can be taken according to your budget. Wireless, we have our own wireless network. Easy to install. Because of wireless network, our systems are plug and play. And we assure a saving of 20% of energy through a unique control algorithm. And our systems are cloud-based. No expensive server or licenses are required. And we have already done 2,000 plus installations in hospitals, hotels and resorts, institutions, pharmaceutical companies, and so on. With me today, I have Mr. Sunil Reddy, our technical director. Sunil Reddy sir completed his graduation in BE Electronics and Communication in the year 1987 from Osmania University, started Maynard Instruments and Control in 1989, wherein he made his own inventions which were applicable for major industries, Indian Railways and Indian Navy ships. Some of his inventions were the instruments for checking transistor testers, bearing testers, monitor for battery charge discharge, and non-contact temperature measurement systems for process plant. He also developed automatic grease feeder for bearings, which currently more than 2,000 are in use. Mr. Reddy wanted to enter the automobile sector, which are gaining momentum. He went on to start up ProTech, Progressive Technologies, in 1996. Mr. Reddy's commendations are 92 modules of wireless building automation systems, which are in a game changer in FM industries, which guarantees energy saving to up to 25 compared to conventional type. In 2019, Mr. Reddy was awarded the Best Innovation Solution from McDonald's India for the same, wherein he proved saving of rupees 6.5 million per annum for 300 plus McDonald's stores in India. Mr. Reddy's vision was to take this innovation product worldwide, so made JV company with Digital Dots US based company. Talking about Mr. KP Dominic, MD Blue and Gray, he has 36 years of successful and satisfying experience in fire safety and security domain, founder of Fire and Security Association of India, FSCI, established in 2002, served as the marketing and event chairman for 11 years, general secretary for 4 years, and immediate past president for 2 years. Served in the association for over 18 years to develop the fire industry in India. Founder member of Forum of Critical Utility Services, Focus, current Southern India chairman, and responsible for marketing and events as a chairman. Committee member of National Building Code, NBC, started the professional career in fire industry in the year 1990, worked in various positions and as country head in Mircom, Honeywell, Vista, and DADS. His goal, educate and create mass awareness on fire safety and make safety as a way of life. Specialty, marketing events, business development, and motivational speaker. And I have with me Mr. Karthik, our marketing MD, and he'll be doing the presentation for us today. Over to Karthik.
Yeah, thank you, Nisha. Yeah. I'm just sharing my screen.
Yes, I'll stop my sharing.
Yeah, a very good morning, everyone. And this is Karthik here, and I'm here to explain you about our wireless and cloud-based intelligent building automation system. So the system has been designed in such a way that the system not only helps the clients in monitoring and controlling all the utilities, but also in energy savings. So brief history about our Protect the OEM. So we are established in 1992 with in-house R&D and manufacturing of various quality products based on microprocess systems. We are recognized as a pioneer in our field by our customers. Led by our CEO, Mr. Sunil Reddy, we have more than 30 years of experience in design, development, and manufacturing of microprocessor-based instruments and control systems. We are an ISO 9001-2015 certified company. When it comes to a traditional building, we have multiple utilities such as HVAC, lighting, fire pump, restroom, energy management, water tank, DG, elevator, LPG, air compressor, cooling tower, UPS, and many more. Now, managing and controlling all these utilities is a tedious task for either the engineering department or the facility manager, as they are dependent on manpower for either monitoring of the systems or controlling of the systems. And in this due course, a lot of energy gets wasted. Now, let's take an example of HVAC, which forms the major chunk of energy consumption. Almost 60% of energy consumption comes from HVAC. In a typical office scenario where offices can start at around 9 a.m. in the morning, typically pre-cooling starts from 8 a.m. at a fixed temperature of 24. Now, instead of doing that, if they can start the air conditioning at around 7 a.m. in the morning at a temperature of 28 degrees and reduce 1 degree every 30 minutes. So by the time it reaches 9 a.m., it will have a similar effect of 24, but that small plan can help you with a lot of energy savings. Similarly, at the end of the day, when the guy has to go to each and every floor to switch off the air conditioning and lightings, it causes a lot of energy wastage. Similarly, clogging of the filters is another concern where it causes more energy consumption. The more is the clogging of the filter, the more will be the energy consumption. Similarly, energy meter mapping. So readings are taken either every 12 hours or 24 hours. So that doesn't give you any idea regarding the energy consumption pattern. Now coming to water. Now, water is one of the most neglected resources in any commercial building. Now, we don't know how much amount of water is getting consumed at which place, or how much amount of water is wasted. Similarly, at the fire pump, where we don't know the status of the jockey pump, how much time it is running, what is the current level of water in the fire water tank, the runtime of jockey pump, and many more, the diesel pump, fuel in the diesel pump, and many more. Now, considering all these challenges, we have a solution where all controls and monitoring is on a single platform. And we have designed the system in such a way that it's affordable. When I talk about affordability, you can install our system either from a 1,000 square feet office to even a multi-story building to even a spread out campus. We have a solution. Then all our modules are smart and wireless. So what happens here is we have a main controller and all the sensors attached to the controller itself. The data gets collected and transferred wirelessly to a central console. And being a wireless solution, it's very easy to install. It's so easy. Let's say we have a multi-story building. Let's say typically 15-story building or 20-story building, which has around some 40 to 50 AHUs or some 120 energy meters and all. We can install our solution in 8 to 10 weeks, approximately ideal time, sir. And then wherever we have done our installation, the average energy saving is around 20%, sir. And last but not the least, it's a cloud-based system where the client doesn't require any kind of an expensive software or a server system. They just need a laptop or a desktop with an active internet connection. They can access and control the data from anywhere in the world at any given point of time. Partial list of applications: HVAC temperature and timing control, lighting control, signage control, AHU filter monitoring, energy management, restroom monitoring system, water tank level and control, DG monitoring, chiller monitoring, elevator, air compressor monitoring, cooling tower monitoring, fire pump, UPS monitoring, and many more. Now, how the system works. So any building, whether it's a new or an existing building, if it's an existing building, we do a site survey of the building to understand what are the list of utilities that are required to be monitored and controlled. And once we do a survey and have a complete list of it, we bifurcate the entire building into multiple areas. So each area is allocated a gateway. This gateway is nothing but a communication bridge between these individual wireless modules and to the cloud. So different modules are attached to communicated to this gateway, and they are transferred to the cloud, sir. So the communication between the wireless and the gateway, wireless modules and the gateway is through LoRa, and from the gateway to the cloud is through GSM communication. Now, why? So our system, intelligent building automation system, is truly modular, which means any decision can be taken as per requirement and budget. It can be expanded as per the building requirements. Second, we have standard modules for each utility and facility for add-on sensors and modules as per the client requirement. This I will explain as I proceed further into the presentation. Then it's a wireless system, hence ease of deployment across the building. Takes days or weeks to complete the project. It's a simple and easy installation based on latest IoT technology. And then we have robust, expensive online software and cloud charges. Then data logging every 10 minutes, and we can provide faster data logging as per the requirement. Then we have complete data analytics with hour to hour, day quarter to day quarter, day to day, and week to week, and month on month comparisons. And in the due course, we provide an average savings up to 20%, sir. In a nutshell, we listen to you and we provide solutions as per your requirement. So a brief milestone. So we started our automation journey in 2014 by providing diesel tracking system for McDonald's, and from then on, by coming to we are the only sole automation vendors for McDonald's. So based on the feedback and the experience from McDonald's, we started developing modules for buildings, bringing ease of installation without complex wiring across the building. And the prime focus started was on retrofit as well as other chain of retail stores. So we have different modules such as energy mapping, your cold room monitoring in HVAC, AHU chill water type, AHU monitoring and controlling, DX type monitoring and controlling, cooling tower monitoring and controlling, fresh TFM monitoring and controlling, water level, tank level monitoring, water tanker delivery monitoring, water flow monitoring, restroom monitoring, fire pump monitoring, status monitoring, machine runtime monitoring, air compressor monitoring, any electrical equipment on-off control, lighting control, UPS monitoring. So we have more than 90 plus modules of different variants. And the installations include, like, for example, hospitality, we have Trident Hotel Hyderabad, Oberoi Bangalore, and malls, we have Angkor Paul, Malaysia. In retail, quick service restaurants, we have Barbecue Nation, McDonald's, and many more. In hospitals, we have Apollo Hospitals, Hyderabad, MGM Hospitals, Chennai, Nanjappa Hospitals in Shimoga. And in coming to other segments such as pharma, we have Glenmark's, Milax, Palomar Biosciences, Sun Pharma, and many more. So what we want to highlight here is we have more than 2,000 plus installations all over the country. So why it's important? First of all, in today's scenario, it's very important to reduce the energy cost, as it's very important. It has to be economical as energy costs are rising. And then you have to reduce the risk, reduce the demand for energy, control energy demand based on the requirement. And then last but not the least, it's reduce carbon emissions. So reduce the carbon footprint, promote a green and sustainable image. So we have a saying, if you cannot measure and analyze it, you cannot control it. So our system is a web-based wireless sensors and control, can measure the utility wirelessly, as a low cost of installation because the number of days required to install reduce. So we are reducing the installation, and can be expanded as per the building requirements. So the system in a nutshell, sir, in a summary, collects data and sends to the web server. It receives instructions from the web control. User can analyze the data and give further commands to control. Against the system applications, we have HVAC, automated lighting control, DG monitoring, water tank level and flow monitor, pumps on-off control, air compressor monitoring, equipment on-off control, fire pump monitoring, status monitoring, cold room monitoring, chiller plant manager, cooling tower monitoring and control, restroom monitoring, temperature and RH monitoring, energy monitoring, LPG monitoring, indoor air quality index monitoring, freezer chiller monitoring, and gas consumption monitoring. The key features being remote controlling and monitoring of the entire facility. You can automate and take control of various operations. You can manage all the system, coordinate with various systems. You can provide a comfortable working environment in an efficient way. You can control or monitor and optimize the building service, reliable and cost effective, recording utility consumption, reporting and analysis, and alarms for crossing preset limits. Now coming to the main parts of HVAC. So we have the following monitoring and controlling modules for the following HVAC related products like AHU package, AHU chill water type, split window, VRF, VCD, chiller monitor, chiller pumps control, cooling tower monitor, cooling tower pumps, primary and secondary pump control. Now coming to the main module. So this is the module which we have for chill water type AHU, where we can give an on-off command, know the on-off status, set the temperature, measure the return air temperature, measure the supply temperature, measure the delta T of it, and then measure the chill water supply, chill water return temperature, monitor the clogging of the filter. We have the 0 to 10 volt actuator control and feedback, 0 to 10 volt VFD control, fire input status, and trip status. Now to this, if any client requires, like for example, let's say what is their RH monitoring, they want to monitor the RH in the return air duct or the CO2 levels or anything, or a fresh air damper control and all, depending on the requirement. Yes, we have an additional module. So this module has a facility where I can add an additional module as per the requirement. Now, there might be some cases where you already have an existing BMS system, but you don't have a way to control your actuator. For that module, we have a simplified version of this module called wall control module, where by knowing the on-off status, we can set the temperature, measure the return air, measure the supply air, measure the chill water supply, measure chill water return, and based on these parameters, we control the actuator between 0 to 10 volt and feedback serve. Now, I request my CEO, Mr. Sunil Reddy, to explain about how we are able to save energy through our AHU module. Over to you, Sunil, sir. Sunil, sir.
Yeah. Good morning, everyone. Yeah. So we have a special algorithm here. So we call it as a delta T manager. So generally, if you you want to get a maximum benefit of reduction in the energy of the chillers, you have to come from the low side instead on the high side. See, high side, if you're doing any type of control is maximum, you can do a chill water reset. But from the low side, there are a lot of benefits, and we have proven this benefits, and in locations we have reduced the chiller power consumption by almost 30%. So we have a logic called as a delta T manager, which is implemented in our AHU control module. So basically what this does is it increases the return temperature of the chill water. So this in turn increases the evaporative pressure in the chiller. So then the work done by the compressor is automatically reduced and less power, the chiller consumes less power. So this is the technique what we use without compromising on the cooling condition, comfort condition. So what all sensors we use is we measure the return air temperature, supply air temperature, chill water supply, and chill water return. So based on these 4 parameters, we have an algorithm where we work on and modulate the actuator. So in the process, one thing is not only that chill water return temperature is increased, which will help in efficient working of the compressor, and it also reduces the requirement for the chill water, so that your pump energy also is saved. So in the process, a minimum saving of 20% can be achieved in most of the locations where we have put. Right now, we have more than 1,000 installations of this chill water controller of the AHU module, the delta T manager. So we have average savings, it varies right from 15% to 42%. And average comes to say about 20 to 24%. So this is a technique, and this can be implemented if in spite of having BMS on top of it. Also, this can be implemented, and it if you want a complete automation, we can provide you both. Yeah, go ahead, Karthik.
Sir,
go ahead. Yeah, go to the next slide. Yeah.
So now coming to water management, so we can measure the water tank levels in liters and link it with pump out of control, which is totally automatic. Then we have a solution for a water tanker delivery. And then if you have water meters with either pulse output type or RS485 enabled communication port, we can integrate that water meters and provide the data on the dashboard. So a small water table, we want to highlight here is we can manage what are the sources, we can monitor the consumption from multiple sources, what is the expenditure from a multiple areas, and etc. So in a summary, so you can monitor remote controlling monitoring of the entire facility. You can monitor all your input water flow, that is municipal water, bore water, and water tankers. Monitor your output water flow. Remotely manage all your pumps, on-off control, pump runtime. View real-time water tank levels. Coordinate with various valves in systems. Monitor and control on-off and runtime of STP. Recording of the utility consumption, reporting and analysis, and alarms for crossing preset limit. So coming to the next parts of which we want to highlight is on the safety aspects of any building is the fire pump house monitoring system. So the product has been designed keeping in understanding the multiple challenges which we have observed in during our survey, like the motor pumps, instead of being kept in auto, they're either kept in manual or off. The jockey pump is running regularly, hydrant pressure not being maintained properly. The water in the fire water tank is used for other purposes such as gardening and cleaning of the corridors. And we have observed pilferage in the diesel pump. So so we have a solution where we can check the status of hydrant pump, sprinkler pump, jockey pump. And if you have a booster pump, we can also check the status, that is auto manual status, on-off status of the pumps. Then monitor each machine running hours. Then monitor all your diesel pump, that is what is the current fuel level, how much amount of fuel that is filled, how much amount of fuel that is consumed, and battery voltage, as well as monitor your line pressure, not only at the pump room, but if you want line pressure monitoring at any other location, we can provide that. Then monitor the fire water tank levels. The data is updated every 10 minutes, and then we have smart data analytics to monitor the situation, sir. Now coming to DG monitoring systems, so we monitor the following parameters. So it's fuel level in liters, fuel filled in liters, fuel consumed in liters, the generator on-off status, running hours, and we can integrate with, if they has a communication port, so through Modbus, we can integrate with through RS485 communication ports, sir. Then we have switch control and status module. So this module is used to control any machine such as your lighting, pumps, electrical kitchen equipment, elevators, escalators, exhaust fans, any electrical equipment. And the status monitoring module can monitor the on-off status, trip status, auto manual status, or any other status as per the requirement. We also have solutions for gated communities where we can control the outdoor as well as corridor lights, monitor of the water consumption, and then DG monitoring as well as fire pump monitoring for gated communities. Now coming to the system components, on the left hand side you can see this is the gateway, which acts as a communication bridge between the wireless modules and the cloud. So the left hand side of the antenna on the left is for intra communication, and the smaller antenna is a GSM antenna which is used to communicate to and fro between the cloud. Then we have an excuse me, yeah. So this is my energy meter. So any energy meter with RS485 communication port, available port, we can integrate with those energy meters, or we supply energy meters as per the requirement. Then this is a fuel sensor module for DG. So this fuel sensor is custom manufactured based on the height of the diesel tank. Then this is temperature, humidity, flow, pressure module. Then this is the module for all your ductable DX type systems. So here there is a provision to keep the sensors for supply air, return air, monitor the filter, then unit control and compressor control, sir. And these two modules are used for controlling your any IR based split or cassette AC units. So we can set the temperature, schedule the on off of the AC, and monitor the room conditions, sir. And please note, this is the module for the chill water type AHU. So here we provide sensors for each and every system, sir. So here you can see there are 4 sensors. So here the 4 ports here. One for return air temperature, one for supply temperature, one for chill water supply, there are chill water return. Then you have actuator control, actuator feedback, VFD control. On the left hand side, you have 4 status input ports for on-off status, trip status, auto manual status, and fire input status. On the right hand side, you have a port for on-off control of the AHU. On the top of it, here you have a provision for to keep the filter sensors. Now to this module, we have something called as an expansion port, where depending on the requirement, like for example, monitoring of relative humidity in the return air, or CO2 levels in the return air, or fresh air damper control, or any other equipment, electrical heaters and all, we have through this port, we can add additional modules to this module and control the equipment, sir. Then this is our switch control module, pump compressor cooling tower module, if it's a QSR or any kitchen which you are providing, so we can have the LPG consumption, sir. So we have wide variety of applications, hotels, retail outlets, restaurants, hospitals, petrol pumps, farmers, industries, education institutions, offices, chiller compressors, energy consultants, tourism industry, chemical reactors, waterworks department, diesel tracking, industry production lines, convention centers, and many more, sir. So let me show you a couple of analytics of how our page looks like. So this is our home page, sir. So this protectbms.com is the site where individual customers can log in using their username and password and check their data. So let me show you some demo data, sir. So once you enter, you get this page, you select the building management. So now this has been designed in such a way that, like, if a client has multiple properties across multiple cities, they can select the city, and in the city you have multiple properties again, they can select a particular property. So here on the left hand side, it shows what are the list of utilities which we are monitoring and controlling. So this is because it's a simulated data. Here we are only showing the data. We do not have any control access on it. Yeah. So here you can see this is based on one of our site where we have there are two main energy meters as well as 30 odd sub energy meters. So we have bifurcated into AC, ballroom, DG aux panel, elevators, guest rooms, rising main, kitchen, laundry, lighting, like that. So here total we get a data of all the list of energy consumption from midnight to now. So this is the data which we can observe here, sir. Now coming to the air conditioning system AHUs. So again, area wise for P3, for example, this P6, there are some 5 AHUs. You can see the status, you can see the set temperature, return air temperature, supply air, the delta T, the chill water supply, chill water return, the actuator level, filter pressure and feedback. If you want to see the simulation, just click on that and your simulation will open up. So you can see where your supply air is, where your return air is, chill water supply, chill water return, actuator level, feedback, sir. You can get the data. Similarly, if you have an LPG flow meter provided by us, then we show what is the consumption at each kitchen at each kitchen. So 5 kgs is the today consumption from midnight to today till now, and LPG meter 2 has consumption of 16.6 kgs. Then temperature monitoring, area-wise temperature monitoring, that also we have. So you can see the different temperatures that is getting monitored. So the facility manager or the engineering department can easily monitor all their parameters. And then we have alert system where any parameter crossing the threshold limit, they will immediately get an email alert, sir. Let me take you to the analytical graphs. So we have parameters like for example, consumption parameter is like the electricity consumption, LPG consumption, unit runtime and all. They come under the consumption parameter, sir. Then coming to the reading parameter like your temperature reading, pressure reading, chill water supply temperature reading, chill water return temperature reading, like that, fuel levels, they all come under the readings, sir. Supply versus utilization is like as a name. If we are doing a complete energy meter mapping of the entire building, so by taking the mean meter reading and we'll populate the data as per the consumption parameter. So let me first show you the consumption. Let me take you to a wholesome data. So from 1st of November to here. So you can see what is my consumption on an hourly basis. So where my peaks are happening. And then coming, for example, let's say, let me take you to substation room, which will give you more idea. So you can see from 1st of November to 12th, you can see what is my cumulative hourly consumption, and you can understand where my energy consumption is happening at what time. So you can see major consumption happening after 9 AM all the way till between 1 PM. After that, it stabilizes, again reduces as we go end of the day. So on a day-to-day comparison, so you can see the 1st of November, this was the consumption. Second, this is the consumption. Third, this is the consumption, like that. Now, if you want to see day quarter, like where most of the consumption is happening, you can see between 12 PM to 6 PM, most of the consumption is happening, followed by morning 6 to 12, and later evening 6 to 12, and then later on midnight 12 to morning 6. On a day-to-day comparison basis, you can see this particular site, more consumption happens during Tuesday, Wednesday, Thursday, and Friday. And then if I want to compare week 1 to week 2, this is my comparison, sir, and total monthly consumption. Now, today's, if I want to see only numerical data, I just select the click on data and I'm getting all the data in numerical, sir. And as I proceed further, you can see date-wise numerical data and all. So we have designed it such a way that it's easy to copy and put it in reports, sir. So this is on the consumption parameter. Let me take you to readings. Yeah. So for example, let's say if I have to monitor the temperature reading of any particular area, so let's say this particular temperature parameter, you can see what was my average temperature maintained during this particular hour. For example, if it is 00 means 00 to 0059. So like that, this is the average temperature. During that time, what was my maximum temperature, minimum temperature, and average temperature, like that. So this is an hourly comparison data, sir. So if I want to see on a daily basis, you can see, okay, on 1st of November, the temperature varied between 8.2 degrees to 26.9, with average of 16 degrees being maintained. Or if I can say 4th of November, where minimum was 25, maximum was 57, average was 37. So here I can understand what is my different temperature parameter. Let me take you to HVAC. It will give you more data. So let me take this one particular AHU, sir. So you can see what is the actuator feedback, actuator level, then chill water return temperature that is being maintained across during the entire day, the chill water supply temperature, the delta T, the filter pressure. So you can see all that data, sir. You can see what is the typical filter pressure that is being maintained from when and where, like that, sir. This is all on the readings data, sir. Now, when we do a complete energy meter mapping, we have something called as a supply versus utilization. So just give me a minute, couple of seconds. So once the entire energy meter is mapped, so this will automatically populate into multiple segments. So you can see chiller panel 2 is consuming 17.9%, panel 1 is consuming 6.86%, then your lighting panel is consuming 11.58. So with this system, you can have a data where you can identify where your consumption is happening, most of the consumption. Now, if I want to group it, let's say all AC into one place, so total consumption from AC is 27%. Your guest room is almost 15.8%. Kitchen is consuming 7.6%. Laundry 1.3%. Lighting is almost 13.4%. Plumbing 4.58%. PP and BOH almost 8.43%, like that. So this will help you in identifying, understanding where your consumption is happening. So this is all on the analytics part, sir. And you have on a dashboard, so you have you can download the daily reports, like raw data, like hourly report, daily report, on a daily based transaction report. Transaction report means every 10 minutes. So for example, for hourly and daily, you can select a time period of 1 month as a single, and you can download the data set and view it, sir. So this is all about our system, sir. Now I request the participants, if you have any queries, please feel free to ask, sir.
Karthik, we have few questions from the attendees. So shall we start responding to the questions?
We have some couple of questions.
Yes.
Yeah, go ahead.
The first question they have asked is how the data are
transferred from modules to gateway. Mr. Arjun,
Yeah.
the question is from Mr. Arjun.
So there are some questions which are asked in Q&A.
Yeah, stop screen sharing, Karthik, so that bandwidth.
How the data are transferred from modules to the gateway.
Yeah, this is through
So
LoRa.
let me take you to the schematic again, sir. So here, so as I mentioned earlier, sir, so we have multiple wireless modules for each utility. So once the data is collected, it is transferred wirelessly to the gateway through LoRa communication, sir. LoRa is called long range wireless communication. So through that communication, it is get transferred to the gateway, and from the gateway, it is then transferred to the cloud through GSM communication, sir.
Yeah. Go to the next question.
Yeah.
A question from Mr. Prabhat Goyal. With such intelligent systems available, energy service companies should be taking up running of commercial buildings on saving sharing basis. Is this happening? What is the bottleneck in getting ESCO business started in a good way in India?
Yeah. Coming to this point, sir. Yeah. Because, sir, now we are basically right now into the capex model. So we haven't gone into the ESCO business yet. So ESCO business means the laws are not very clear, sir. So the reason why we also didn't, because we are also thinking to get into it, but because we face some hurdles with a lot of customers here. So that's the reason we are not getting into this ESCO business, but we have a future plan to get into the ESCO business as well. And because we have been showing savings in a lot of areas. So our next plan is probably by next year, we'll be getting into the ESCO business as well.
Right.
Okay, so the next question is from Mr. Prem. He wants to know, will your solution sit over and above BMS system or supersede the BMS system? Also, BMS system already doing whatever you have highlighted in your screens. Yeah. Water consumption, fire protection integration, only you can monitor, then that is the case, no power energy consumption will not be achieved. Please advise.
Yes, sir. Actually, sir, I think there's a little confusion. So this is what we are, the product is a wireless BMS only, what we have presented today. So now coming on to the, sitting on top, see, we talked about the Delta T manager on the AHU. So, the BMS doesn't do any Delta T manager. It only, it's basically a valve control, this thing. So we have a module, in spite you have a BMS, because with the algorithm, what we call as a delta T, can be implemented even there is a BMS. So that's what we meant to say. So it is not like, you have BMS and we don't have, we have developed this product for the BMS customers, that only one module. Our product is a complete BMS solution. So probably I've answered this. So, and in the HVAC, we can guarantee a minimum saving of 20%, even you have BMS, by our unique delta T algorithm.
Hello.
Yeah, Mr. Kim.
Yes,
Good morning,
sir.
Actually, during the discussion, you were discussing like you will control the evaporator. Sorry, the condenser side pressure.
No, not on the condenser side pressure. So we are talking, see, sir. Now I'll again brief you the whole thing, sir. See,
So
what
can
we're
you,
doing
can
is,
you if you don't mind, can you go to that slide?
yeah, Karthik, go to the slide, Karthik.
Yeah.
So
Yes.
increase in chill water return temperature results in increase in evaporative pressure. So the work done by the compressor is reduced. This is our technique, sir.
So you increase in chilled water return. That means you
Yeah, we increase, sir, return. See, now most of the chillers, sir, you find the delta T about 3 degrees, 2 degrees. Okay, but the higher the delta T, the better the chiller performs, sir. So we increase the return temperatures here.
increase in the return, which means you are creating more demand in the field side. Basically, you guys are not doing any changes in the chiller part, right?
No, this is not. That's why I said low side. This is what we are doing on the low side. See, maximum what you can do on the high side is a condenser reset temperature only. You can't, you won't have any control on the chill water return, and only you have a control on the supply, but not on the return. Yes, sir.
Yeah, I got your point. And one more question we raised, like, do you have any control philosophy for the RH control relative humidity?
Yeah, we have, sir. Yeah, that's what we do in the pharma industry. So, are you from a pharma industry, sir? How is it, sir?
No, we are from building automation and controls.
Yeah. So there are two ways of doing it. We have a dew point control system where we can control the room humidity and temperatures.
My question is, because some of the areas we have to maintain some certain relative humidities, which is feeding like data halls or some data centers. Yeah. So basically, we were discussing about the temperature control and delta T. So some of the equipments are coming with cooling coil as well as
and
the
heater.
heater.
Yeah.
So
yeah, I'll come to that.
A specific module or a specific algorithm to control both simultaneously.
Yeah.
But
yes.
at the same time, we need to save the we need
Energy.
to focus the energy saving too.
Yes, yeah. This we are already doing in the pharma industry. So basically, you have a chill water supply with a heater. Okay.
Exactly.
So here, what we do, sir, because traditionally, generally what you do is use relative humidity for controlling the heater, isn't it, sir? Yeah. So, but the very definition of relative humidity is related to the temperature. So what happens is, because this we have observed in the pharma industry. So, and you try to, operate it at a very, if you really plot it on a psychometric chart, at the high energy consuming level, you have to operate it because the relative humidity is always varying. So here we have developed a technique called dew point sensing. So with dew point, we have a dew point sensor on the supply side. So based on that, we control the actuator as well as the heater. So, and in this process, you can save almost 20% energy. The heater usage itself will come down so drastically. Here we don't use a return at temperature technique to control it. We use the dew point sensor here.
Mr.
Can you just leave your telephone number and all those things?
Yeah,
you can put it clearly onto you. Yeah, based out of which place, sir?
So can we move to the next question?
Yeah, okay. Yeah.
Yeah,
Yeah.
just a minute.
So the next question is from Mr. Praveen. Is DX controller communicate directly with the unit control? What type of communication protocol required from unit manufacturer? And what point we can see and monitor in the BMS?
Yeah, so the DX are what, because generally DX units do not have any communication control. So what we do here, sir, we you have the remote control. From there only we do the connectivity, and so it's a hardware thing for the DX units. And from there we take it up and we give all the parameters, like, you can set the temperatures, you can switch on and off the unit from the BMS. And I think you have seen in the presentation, a complete simulation also will be available for you.
Okay, sir. So next question is again from Mr. Prem Kumar. 20 or 30% of energy savings, how can we declare? It's based on last year versus current year bill, or what is the exact procedure to monitor and confirm real-time energy saving?
Yes, sir. So now answering your question, sir, now because we are saying this 20 to 30% is on the HVAC. So what we generally do, sir, we do a POC for a lot of customers. So what we do is we put our system there and we show them the readings, we take for the first 15 days. And then we put our controls and show them in the next 15 days. So that, because we put all the meters, everything. So that is a clear differentiation. You can see immediately. That's how we do it, sir. So it is not like with controls and without controls, we demonstrate it and show it for one particular unit, and that it goes to every unit.
Yeah. Moving to the next question. Does the system work successfully in airport terminals like Hyderabad Airport, where a high capacity central AC system is installed and there are more than 300 AHUs? From Susan.
Yeah, Mr. Susan, see, this is very, a perfect this thing. Actually, Monday I'm visiting your place. Probably if you are from that place, you can share your number because Monday I'm in GMR Airport. So we are already in discussion with GMR. So it is a perfect candidate for this.
Next question is, could you explain how you can save energy on AC plants again? From Jerome.
Yeah. Mr. Lobo, this is, I know, as we explained, this is basically we have something called as a Delta T manager. So Delta T manager is nothing but we have a special algorithm by measuring the supply return air temperature and chill water supply and chill water return. We modulate the actuator without compromising on the cooling performance. So, and we try to increase the chill water return temperature. This in turn, increases the evaporative pressure. So the work done by the compressor is reduced. So the compressor works more efficiently. So this is what the whole, the whole algorithm works on.
So next question is from Mr. Praveen. What is LoRa system?
Yeah, LoRa is a wireless technology, sir. It's known as long range technology. So like even in a building, like, even you have multiple stories also, the signal will be transmitted with ease because it is a narrow band frequency. Unlike like Bluetooth and all, they're all high bandwidth. This is a narrow band frequency.
From Muttumari, how many modules can connect in one gateway?
Yeah, it all depends on what type of modules you want to connect. Like, for example, you're looking at energy meters, you can connect up to, 100 energy meters on a module. And, for air conditioning systems, because of the control complexity, we use, we recommend about 15 of the HVAC modules to be connected to one gateway.
Yes. Sir.
If
So
it is data collection only, then we can go up to 100 modules. If it's only, the control part and all, then, based on our customer requirement, we suggest that.
Yes, sir. So next question is from Mr. Prabhat. Is there any possibility of Matter compatible devices such as sensors, plug outlets, status indicators getting placed in your system? This increases the accessibility of sensor, etc. for the consumers.
Is there any possibility of Matter compatible?
Yeah, hi. This is Prabhat Goyal here.
Yeah.
Can you hear me?
Yeah. Good morning, Mr. Goyal. Yeah.
Good morning. First of all, my compliments. You understand your air conditioning and your controls pretty well compared to a lot of people in the country. But you need to go a step higher in time to come.
Okay,
now,
sure.
I'm not aware if you are aware of the Apple compatible systems.
Yeah.
I was in the US for the last 3 months, and you can see them bringing it to commercial space also. Okay.
Yeah.
So previously you had things like Thread and, forget the Bluetooth. I would say Bluetooth has developed much more than what you have mentioned about broad bandwidth and things like that.
Yeah.
What is coming in today is basically intercompatibility between Amazon, Google, and Apple. All right. And these sensors, they are widely available now on Amazon for delivery.
I got your point. Yeah.
Akara and other things. And really, when you talk about toilet control systems and very simple stuff, which does not require all this rocket science of mapping and monitoring and other things, can be done at a much cheaper price.
Yeah.
And then the more difficult stuff like valve actuators and other things can go on a more difficult system.
Yeah.
And that's when the customers will get the full bang for their buck.
Yeah, exactly. Yes.
So that was my question. I'm sure.
Mr. Prabhakar, probably no, the way we started also. See, anyone who started with the monitoring system only. Okay, so we initially started with the monitoring. So now, as you keep going, so once you do the monitoring, then the most of our customers are asking, okay, after monitoring, what is that next you have to do? Okay, so the next part is only automating it.
Yes.
Yeah, so that's how we got into automation. And what we found is, because we have been collecting data from 2014. Okay, so, and we found lot of energy is being wasted on the HVAC side, and that too on the low side, and it is being neglected. So people are only concentrating on the chiller, but no one is concentrating on the low side at all. So
you're absolutely right.
Yeah,
you're 100%
based on our data, we pulled the data, and we went through the data. This is a lot of work what we have done, and we came to a conclusion that this can save energy, and that's how we got into this. Yeah. And similarly, in the pharma industry also, we did a lot of work on the pharma industries, and the way they were operating, now if you really compare with our new system where we have changed the complete pharma sector, and a lot of people are surprised seeing the savings itself.
Correct.
So we moved from the old way of controlling the humidity. So the very definition of relative humidity itself is relative to temperature. So now you are trying to control something, as the temperature varies, humidity varies, then your goalpost changes immediately. So we have developed a unique way of doing, developing sensors and algorithms and all. And pharma uses dehumidifiers. So we have cut down the dehumidifier usage by almost 60%. And that is a big power guzzler for them.
Correct.
Yeah. So now here, we are coming in a different way. So we are trying to give us a customer a complete solution end to end. So you come to us, everything is available in one number, under one umbrella.
India is a very large country to start with, and it's very difficult to do it from one particular place. That's one. Yeah. Second is, there is a lot of democratization of this technology taking place. It's got to be more democratic. Yeah. And more people should be able to do it as a DIY system, or a little more than DIY system. Easier stuff, especially.
We have the easier stuff, Mr. Prabhat.
Yeah, so, I believe you are from Hyderabad. You are from Hyderabad, are you? Yeah. So there is a company in Hyderabad which starts with a W, Wozart or something, which has announced the first plug outlet which is Apple Home compatible. Okay. So have a word, look into that particular product, since you are in the same line.
Sure.
Things like those should start sitting on Indian systems.
Okay, sure. Yeah. Thanks for your suggestion.
That is when we will be better off than 90% of people in the world. Let's
Oh,
put
sure.
it that.
Yeah, definitely. Thank you.
Okay,
Thank
I
you.
wish you all the best.
Yeah, thank
I'll
you.
be in touch.
Yeah,
So
yeah.
kind
We'll
of
be in
you.
touch. Yeah,
Bye-bye.
definitely.
Thank you, sir.
Yeah.
So the next question is from Mr. Narasimham. Since it's cloud-based system, there would be a lag. How your system overcomes this issue?
Yeah, Mr. Narsim, see, that's what. See, now where all our modules are smart modules. So, we call it as a edge module, smart edge modules. So what we do is, unlike like BMS, every decision comes back to the system and then the action is taken. But here, like for example, air conditions, say, the algorithm sits in the smart module itself. It is not on the cloud. So we just send the command, you perform this, it keeps performing there. And it keeps on pushing data for our monitoring purpose only. So it is much faster than the BMS because the action happens in milliseconds at the edge module itself. And second question, sir, do you have, we have indoor air quality monitoring modules, sir, like it's temperature, humidity, CO2, then PM 2.5, PM 10, and all, we have the complete range for IAQ, sir. Even like you want to monitor your room pressure as well, we can do it, sir.
So the next question is from Mr. Mahesh. He wants to know.
Yeah. I think there's another question from Mr. This thing.
Yes.
Yeah. So how many gateways to be installed? So we generally come and do a survey. So based on the survey, we'll suggest you how many gateways have to be installed, sir. Yeah. And since all critical equipments are spread across, so how many? Yeah. The number of gateways is equal to the number of SIM cards.
Okay,
Yeah.
sir.
The next question from me is Delta T, our patented technology.
We haven't patented it, sir. It's developed by us, sir. I think Prem Kumar has shared his number, probably.
Yes, sir. So moving to the next question, Mr. Mahesh wants to know, are tanks to be emptied during the installation activities?
No, I didn't get you. Can you just repeat it?
Sir, are tanks need to be emptied?
No, not required. Not required.
Okay, sir. And there is one more question from Mr. Sairam. Cloud-based sensor field device are provided by other companies. What are the advantages of your systems?
So sensor is not the only part here. See, sensors is only a part of it. But we have the other control logics and all those things. That only save energy. Sensor it only gives you information what is happening there. So we are not only a sensor-based company, we give a complete solution for energy savings. Just by measuring, you can't save energy. You have to put a control logic there to save the energy.
Yeah. So moving to the next question, are there any energy saving in lifts and elevators?
So that we haven't done much work. So basically, we're having a lift monitoring system, but because lift is a public use place, so I don't know how we can save energy there, sir.
Oh,
so only lift, we have a monitoring system. We can't promise anything on this energy saving on the lift.
So moving to our last question from Mr. Prem, what kind of fuel monitoring system is available with you? What is the methodology you are using to monitor with BMS?
Yeah, fuel.
Yes, sir.
Fuel is, the two things. One thing is we'll talk about diesel, and another thing is LPG. So for LPG, we have a thermal mass flow meter. So independent of here, because this gives a very fairly accurate reading. And coming to DG, we monitor the diesel level. We have a capacitor sensor. And all these sensors are in-house. We have developed the sensors in-house. So for diesel, it's capacitor type sensor, and with a very great accuracy of even in 500 liters, we can give an accuracy of 100 ml. Yeah,
yes, sir. Yes, sir. Yes, sir. Mr. Vivekanand wants to know, is all sensors and hardware manufactured in India? Who are the manufacturers?
Yeah, we only manufacture our own sensors. The basic element we purchase, the rest and all we do it ourselves.
Yes, sir. That was our last question from our attendees. So any more queries, please feel free to mail or send us.
Yeah, sure. You can get the presentation, Mr. Sudesh.
Yes. So please feel free to mail us any of the queries. Thank you everyone for joining in our this HVAC, especially the exclusive HVAC webinar. And thank you, Mr. Karthik and Mr. Sunil.
Yeah,
I
and
hope you all
I
have
just
a-
want to put, like, regarding this HVAC, if people are interested for a POC, we are ready to do a POC and show them the savings.
Yes, sir.
Yeah, so probably you can take a call on it. Anyone.
Thank you everyone and hope you have a great weekend. Take care.
Yeah.
Bye.
Thank you, sir. Thank you, everyone, for your valuable time.
Yes. And for
Thank
the
you, everybody.
presentation, please send a mail. Thank you, everyone.